Okay, so I'm going to illustrate how these data structures work by drawing them out so you can kind of get a visual representation of how these data structures would look like, okay? So first we're going to start with lists. And a list is pretty self-explanatory. It will look something like this. So you can imagine a list to have a structure like this, where we are actually counting the positions in our list, okay? So this will be, let's say, the first position, and then this will be the last position. So suppose this list over here is supposed to be a list of the top 5 most popular games, for instance, okay? So I'm going to fill it in with some data. So as you can see here, we started adding some data to our list over here. And then this is basically the first place. So in first place would be League of Legends, and then Rainbow Six will be next, Counter-Strike, Minecraft, and can you guess what the last one will be? Drum roll please. Call of Duty. So this is essentially what a list will look like. It's pretty self-explanatory. There's just some ordered data. So now the next data structure we're going to talk about is a set. And before we talk a little bit more about the set, let's just take a moment to acknowledge how perfectly round this hand-drawn circle is. Damn. I'm just joking. It's not really hand-drawn. Yeah, so let's go ahead and add some data to this set. So now we have some data in our set, okay? And the main difference between the set and the list is that one maintains a specific order, one is ordered, and this one is not ordered. So if you add an item to a set, there's no specific order. If I wanted to access an item from a list, I can say, give me whatever is at index 3, and I'll get this item. But I can't do the same thing here because it is not ordered, okay? And another main difference here is that in a set, everything is unique, okay? So if I was to add another data called ABC, I won't be able to do that. We'll basically replace this ABC over here, and I'll have only one unique ABC data in here. But on the other hand, if I wanted to add another Minecraft to this list, okay, I can just basically add another position here and then put Minecraft. So I can have duplicates in here, but here I cannot have duplicates, okay? So later on, as we talk a little bit more about sets, you find that there's a lot of unique things that we can do with the set data structure that we can't do with any of the other data structures, okay? So something like this, for instance, okay? We can have a set like this, and it can intersect another set, and we can have data in here, and then data in here, and then the common data that we have between these two will be in here. So if you're familiar with set theory, this will look a little bit familiar, okay? But if not, it's fine. We'll learn a little bit more about this later on. So the next data structure I'm going to talk about kind of looks like this. So then once I fill in the data for this, it will look like this. And we call this type of data structure a dictionary. Okay, so what makes this dictionary unique is that it has kind of a key and value relationship. So if you think of a typical dictionary, you look up a word, and then once you see that word, there's a lot more description for that word. Okay? And basically, this works in the same way, where you have a key, and then that key key has or is related to a value, and that value has the information. Okay, so you can think about it kind of like a variable where we have a name and a value. In the same way, here we have a name and then we have the value that is associated with that name. Okay, but also keep in mind that this is just an example. We don't need to just use one single character as our key. This could be anything. For instance, this could be operating system as a key, and then the value could be Windows. So now let's move on to our next data structure, okay? And it looks a little bit like this. So this is our next data structure, and you're probably thinking to yourself, okay, well, this basically looks like a list. The only thing is that you just put some fancy border around this, okay? This is not just a fancy border. This is to indicate that with this, we can't change the elements in here. So let me add some data in here. So as you've probably guessed, this right here is a tuple or tuple, okay? And like I mentioned, this is similar to this in the sense that they're both ordered, but the difference here is that I can't add an extra element here. So let's say I wanted to add something in the fifth position, okay? With a list, I can always expand and add more. Here, I can't do that, okay? And also, with this one, I can't modify the elements or data objects that is in this data structure, okay? So once you set it, you can't change anything about this. So you're probably wondering, so what the hell do I even need this? Okay? If I have this, I can do a lot more. Why would I use this? And once you start dealing with a lot of information or a lot of data, so let's say you go into an area like big data or machine learning, for instance, you're going to be dealing with a lot of data, okay? And this is more efficient, or it uses a lot less memory in your computer. However, because of the nature of this data structure, this will use much more memory than this would. So this is useful if the data that you're using, you know that it's not going to be changing anytime soon, or you know that you're not going to be adding more data to that object, okay? But I'm just going to go over them one more time. So, like I mentioned with the list, everything here is ordered. And also, we can add more items, so it's changeable. And with a set, everything here is not ordered or unordered. And also one thing that you should note here is that you can't have duplicates, so everything here is unique. And once we talk about dictionary here, this is a little bit special. We have a key and value kind of relationship. Now when we move on to the tuple or tuple, this one is just identical to this. The only difference here is that this is not changeable. So this is ordered and not changeable. So now hopefully you understand the main differences or similarities between these data structures and what makes each one here special.